Alright guys, in today's class I'm gonna prove reduction formula, and let's see how you're gonna obtain this formula. Like I've said before, that reduction formula is very important and it's something that should be taught in secondary school, particularly in further mathematics, because of its application in solving various integration problems. Alright, so it is essential for students to understand this and know its applications. Okay, so in today's class I will only focus on the proof of that. Then from there, once you're able to prove that, then you can leverage on that to solve other problems. What's it called regarding this? All right, so now cos nx dx, this is the formula for that. We have for sine as well, which is actually different from this, but for this one now we have integral of cos nx dx. So the first thing is I'm going to rewrite this as cos n minus 1x, then cos x times cos x dx. I've never changed anything here. By the time you multiply, you have cos nx dx. So we only separate the power to be n minus 1, then product of cos x. Okay, so I'm going to make use of integration by parts. Okay, and the formula for that, we have integral u dv equals uv minus integral v du. All right, so you compare the given question with the left side of the equation here of the formula. So that means u must be cos n minus 1x and the v is cos x dx. Okay, so we need to differentiate u to get du, and we need to integrate the v to get v. So when you differentiate du, you're gonna have du to be du dx, that's n minus 1 cos n minus 2, then derivative of cos x is minus sine x, then you have your dx here. All right, and what else again? You integrate the v. So when you integrate the v here, integral of the v, that's v, and integral of cos x is sine x. So the next thing to do is to apply the result in the given formula, where you have u dv. So where u is cos n minus 1x, dv is cos x dx, then equals you obtained u, we have u to be cos n minus 1x, then v is sine x, minus integral v du. We obtain v to be sine x times du, we obtain that to be minus n minus 1 cos n minus 2x, then sine x dx. And for that of left hand side, when you multiply this, you're going to have cos nx dx, then equals sine x cos n minus 1x. Right, the minus, we have another minus z, so that's going to be plus. N minus 1 is a constant that can be factorized. Then we now have integral of, this is sine x, and we have another sine x here, so that's sine squared x, then cos n minus 2x dx. Okay, so integral of cos nx dx equals sine x cos n minus 1x plus n minus 1. So sine squared x, now we need to rewrite sine squared x in terms of cos squared, and that could be 1 minus cos squared x, then cos n minus 2x dx. Okay, from here you have integral sorry about that, cos nx dx equals sine x cos n minus 1x plus n minus 1 integral of, so use cos n to the power of minus 2x to expand the bracket. That's going to be cos n minus 2x dx, cos n minus 2x times cos squared x, That's going to give you cos nx dx. Okay, so we have integral cos nx dx. Sorry, to remove this. Okay, cos sine x, then cos n minus 1 x, then plus n minus 1. So I want to represent this one to be I n minus 2, since I n is what? Cos n raised to the power of cos nx, that's I n. And remember, this is cos to the power of nx, this is another cos to the power of nx, but here you have minus here, so this is cos nx dx. So by the time you take to the left hand side, that becomes plus, and you're gonna have 2 integral of cos nx dx equals sine x, then cos n minus 1 x plus n minus 1 I n minus 2. So the next thing here is to divide both sides by 2, then you have cos nx dx equals is that going to be 1 over 2? No. Remember, we have a coefficient. I'm sorry about this. This is a very big mistake. Remember, we have the brackets here to be outside the integral to be n minus 2, and n minus 2 here is going to affect this integration and integral sign and this. So we've applied it here, so we're going to have another one here, so which is minus n minus 2. Okay, so let me remove it from here, sorry about that. Okay, so by the time you bring it to this side now, that will be 1 minus n integral cos nx dx, then plus integral cos nx dx equals sine x cos n to the power of minus 1 x dx x plus n minus 1 I n minus 2. All right, and of course, this is by the time you use this 1 minus n to expand, you have integral cos nx dx minus n integral of what? Cos n x dx. Okay, so that's going to be n minus 1. I don't know, sorry about the mistakes. So n minus 1, so this is n, this is minus 1, then plus integral of cos nx dx. I'm sure you get it now. So if you didn't understand, you can actually check back the video, you move it back, then you watch again. So I'm sure you're going to understand that. So this is sine x cos n minus 1 x plus n minus 1 I n minus 2. Okay, and of course this is going to cancel this, so you'll be left with n integral of cos n x cos nx dx equals sine x cos n minus 1 x, then plus n minus 1 I n minus 2. So you divide both sides by n, so you finally have cos nx dx equals 1 over n in bracket of sine x cos n minus 1 x plus n over 2, n minus 1 over 2, n minus 1 over 2, then I n minus 2. And this formula can only be used when n is greater than or equals to 2. So which is the reduction formula, which is the proof of this formula, cos n x dx. All right, so don't forget to like, drop your comment and subscribe. And if you want the reduction formula for sine n x dx, drop that in the comment section so that I can do that in the subsequent classes. Thank you.